Okay, guys, we're going to get started. You guys are quite lucky. I'm an American, so I can talk loud enough that the back of the room can hear me. So what we're going to be talking about today is polyglot data. How many have heard of polyglot data before? Oh, actually, a couple people have. Normally, no one knows what it is. When we start looking at systems, a massive amount of accidental complexity happens simply because we choose the wrong models. And using multiple models is hard, but we're going to look at how we can actually do that inside of production systems. Now, let's get started. You can feel free to yell at me. I won't be afraid. Don't worry. If you have a question, you can stop me. Afterwards, if you prefer, and I know some people in France are uncomfortable speaking in English in large groups. If you prefer, après, je parle français aussi. Okay. So what we're going to look at first is a very, very brief introduction to event sourcing. We will not be spending 15 or 20 minutes talking about this. How many of you have heard of event sourcing before? Wow, I think it's the first time I have more than 50%. Good, so I'm glad I deleted a couple of the slides talking about it even more. So what we're going to do, instead of storing a structural model of some form, instead what we're going to do is we're going to be storing events. Here we have 5 events that will be stored. At any given point in time, I can always replay these 5 events. And I know there's only 3 boxes there, but these are actually 3 distinct events. And I can give you back this structural model. Now, some of the brilliant things about event sourcing. There are an infinite number of structural models that you can look at off of any given set of events. These 5 events have an infinite number of ways of looking at them. But what we store is those events. What this really comes in and allows us to do is to come and make models later. I don't need to come up with a model that I need 2 years from now at the beginning of the project. I can always project out a new model off of the fact that I've got my events. The reason for this is you don't lose information if you store in this model. Any structural model that you use will lose some amount of information. If I store this, this is losing information. And people say, no, it's not losing information. Look, it's there. How many of you have an update or delete statement inside of your system today? Okay, cool. Now, keep your hands up. I didn't say to put them down. How many of you had a meeting with your CEO to decide that that data, based on a cost-benefit analysis, was worthless? So how did you decide to delete that data? How did you decide, from a company perspective, that the company won't need that information in 2 years? How many of you can predict what your company will ask you 2 years from now about today? How about 2 weeks? I have a hard enough time with 2 hours, and I'm a partner of the company. You can't predict this stuff. I mean, all you're going to end up doing is sitting down with a magic 8-ball, shaking it up and going, what will they ask me about today, tomorrow? As a CTO, I only had one rule. I will not lose any information because I have no clue how to evaluate it. How do you plug in the value of information into a cost-benefit analysis? If we start looking at it, how much money does it cost to store 1 gigabyte of data for a year? So let's just imagine we could say that storing 10 gigabytes of data for a year today is roughly the same cost as a Coca-Cola. How much value do you need to derive from that 10 gigabytes of data to break even? I mean, we're talking about rounding errors here. So for me, in most cases, I will say store everything. And we're talking even like 7, 8, 9 years ago. We were storing 100 gigabytes a day. How many of you have 5 gigabytes a day of data? Couple. And I always get the question, so if I'm going to store all of this information for all time, it's going to get big, and then it's going to get really, really expensive. But you need to think about it from a different perspective. Where are you in terms of technology growth? 10 years ago, how much did a 1 terabyte hard drive cost? Today, I'm almost able to actually get a 1 terabyte micro SD that I can put in. They're getting close to it. And I've always said, just so that I saw there were some talks where big data came into play, if I can put your database on a micro SD, it's not big data. How many of you have heard of some of these before? And by the way, the resolution on this thing's really crappy. You are not cool if you don't use these. Well, except for that one. These are the hot new thing, right? Everybody will be using NoSQL in 10 years. How many have heard claims like this? NoSQL is king. SQL databases are dead. Hate to be the one to tell it to you, they all suck. Every last one of them. Especially that one there on the top. But they all suck. Every single one of them. Every database on the planet sucks. They all suck in their own unique ways. Except for that one on the top. But there is no best storage. You will never find one storage that will be the best at everything you ever want to do. By the way, as we talk about NoSQL, how many of you remember these? This reminds me a lot of the NoSQL movement. If you were to go today and tell your company that we're going to use Java implementations with XML and object databases, what would the architects say to you? No, no. But these things were going to take over the world. Remember all the hype about these. And they were great. They were so awesome because you could hook them to your domain model and they didn't have an impedance mismatch. How many of you use an object database today? Wow, that's a lot. There were 2 hands for the camera that couldn't see. Object databases are wonderful when you're using them to back a domain model. They have no impedance mismatch. You don't have to go through any hell of dealing with Hibernate mappings. They are technically superior as well for that task. If I go to a relational database and try to map out of a relational database, how many joins am I doing? When I'm searching and I want to find a row because of another row, I'm going to be searching normally in log n because it's going to be in a tree. If I look in an object database, it's going to be big O of 1. It's a constant lookup. And they're much, much faster. You would find a database backed by one of these, or sorry, a domain backed by one of these to be 10 times faster than dealing with a relational database. So how come you guys aren't all using them today? Well, it's because they suck. So you go off and you build your application on top of an object database. You're getting ready to go to production, and then that stupid business guy that always wants features, he comes up and tells you that he wants a small feature added. It's called a report. And he said, reports? Oh. And he says, well, what I want to see all the customers and their sales, and I want to see them grouped by a month and year, and then I want to see an average and a standard deviation of that. And you go, that sounds like a SQL query. How do I do that in one of these databases? Oh, wait, this means I need to load up 170,000 objects. Crap. So the end thing that we come up with is that object databases suck and no one should ever use them. That makes sense. No, what's really happening here is object databases, while being amazing at backing a domain model, are absolutely terrible at doing OLAP-style querying. They're just not meant for it. You want to start doing set-based operations, and object database is not the right choice for you to be using. The problem is picking the wrong model introduces a ton of accidental complexity into what we're looking at. And when you start looking at your systems, there's almost no system that you will find that has one model that does everything well for it. Of course, the database vendors don't want you to know this. When we start getting into systems, most of the time you're going to want to have 2, 3, maybe even 4 models. It's OK. You can do this. If you don't do it, you're going to start getting into a world of pain. How many have heard of this small company before? It's a new little startup. At their heart, Twitter is a topic-based pub sub. So how many of you, if I asked you to build me a topic-based pub sub, would pick Ruby on Rails and MySQL as your tools of choice? Or maybe you might think that there's this thing called Erlang that people have been using for this stuff for decades, and maybe that would be a good choice instead. And they ran into huge amounts of accidental complexity trying to scale their system because they were built on top of MySQL as a topic-based pub sub. No other reason. They had hundreds of MySQL instances. Do you know how hard it is to manage hundreds of MySQL instances? But we'll see this pattern over and over and over again, where people get massive amounts of accidental complexity simply because the decisions they're making about which models to use. How many of you have had a table like this before? So we have ID, parent ID, and data. And what we're really doing here is we're building out a tree. Perhaps a menu side, or, come on, you can admit it, I've done it. And then you push this out to production. And you get a call from the admin, and he says, I don't understand why this report is taking 9 minutes to run. You go, well, it works fine on my machine. But the difference is, on my machine, I've got 17 rows of data. In production, we have 170,000 rows of data. And what you've built here is known as a recursive query. As the data gets more and more complex, you have to recurse further and further in order to get out your tree. But you guys are all good developers, so I bet you came up with a solution like this. So now we have ID, parent ID 0, parent ID 1, parent ID 2, parent ID 3, parent ID 4, all the way up to your maximum nesting level. And this way I can do a query, and I can say where parent ID 0 equals, or parent ID 1 equals, or parent ID 2 equals, or parent ID 3 equals. And then I get back the whole set of the subpart of the tree, and I can just quickly recurse through it in memory. Well, you could do this. I've actually seen a company, real life company, they were doing something almost like this, except inherently more evil. So what they had was they had a person. And a person had a name and a type associated with it. Don't ask me why a person could be a company. For me, that's a bit odd. That's a whole other story. And that's really more of a domain-driven design thing. And then they had another table, which was called relations. And a relation would connect two people, and it had a relationship type associated with it. How many of you have built something similar to this? So what I forgot to mention was that they had over 1 million people and over 5 million relationships. Now, what they really wanted to be able to do is they wanted to take two people, and they wanted to issue a query. So only based on these relationship types are these two people connected. And they had a $500,000 SQL server to run these queries. Until I showed them another way of doing it. It's called a graph database. And instead of their queries taking 5 seconds, they all finished in under 100 milliseconds. They were running on a laptop, as opposed to a $500,000 server. Why? Because what they had done here is built a graph database poorly. And they had spent over a year on this project. We replaced it in an afternoon. How many of you have a PhD in graph theory? Actually, it's really funny. I did this talk in Budapest a couple weeks ago, and one of the guys actually raised his hand, and he's like, actually, I do have a PhD in graph theory. It's like, oh, triplet. First time for everything. Neo4j has PhDs in graph theory that work on the database. I'm sorry, I trust them more than I trust you to build a crappy graph database on top of a SQL Server. This year-long project was nothing but accidental complexity because they were trying to rebuild the idea of a graph database into a SQL Server. Just moving the data out of SQL, putting it in a graph database, they were done in an afternoon. Accidental complexity comes out of choosing the wrong models. How many of you have used SQL Server or Oracle full text searching? What do you think does a better job, that or Lucene? But I see people using it all the time. The worst is when you get brought in because they're having performance problems. And you say, well, you're doing all your full text searching inside of SQL Server. Have you considered another tool like Lucene? And they go, Lu what? Picking the wrong models brings accidental complexity into our problems. Now, I've been talking about event sourcing and domain-driven design for a very, very long time. In fact, I can tell you, the first presentation I did about it, this isn't the first one. This is actually the second one. This is the one that I did reasonably well. The one before that was much, much worse. It was 2006 at QCon San Francisco. And I had just been working in an algorithmic trading firm. I didn't go to conferences or do talks or stuff like that. And I thought it was interesting, we're doing, 2, 5,000, 10,000 transactions a second with a domain-driven design-based domain model. Could be interesting for some people. And I go to do my talk, in my front row, these are people I've never met at this point, Martin Fowler, Gregor Hope, and Eric Evans. And I think I had had about 20 cups of coffee before I did my talk. I went through my 60-minute talk in like 22 minutes. And I can't tell you the feeling of watching Martin Fowler bring over a red card and put it in the bin at the end of your talk, and you're just like, oh. Eric even told me that was a bad talk. I understood maybe 10 to 20% of what you were saying, which means the rest of the audience basically understood nothing. So I went back and I tried redoing everything, coming up with better ways of explaining stuff. And I came back in 2007 for this talk. I actually really want the video of that first talk. And I did this talk, and then Eric came to me afterwards. He's like, that was a really good talk. And it's like, well, thanks. I've practiced for a year. But I've been talking about event sourcing for a very, very long time, as well as CQRS. Now, when we start talking about having many different kinds of models, there's lots of different places that we can start looking for separation of models. The one that CQRS talks about is reads versus writes. When we talk about reads, reads are normally where all of our scalability issues are going to be, unless you happen to be working in, say, gambling or finance. How many of you do 10 times as many reads as you do writes? My guess is let's try 100 times more reads than writes. And I've seen systems where it was 10,000 times more reads than writes. It's common. Think about The Guardian. That you put something up and then people read it. A blog. Very many systems, their scalability issues are all on reads. They have nothing to do with their writes. Which is always funny because you see people at the big scalability talks talking about their reads. When we start talking about the scalability of reads, we may want to have a completely different model to represent our queries than what we use to actually write to. I'm curious, how many of you have something akin to a third normal form database right now? Roughly third normal. It's probably somewhere between second and third. I like to call it a pragmatic third. Now, how many of you raised your hands that you're doing at least 10, possibly 100 times as many reads than writes? So you optimize for write performance. That makes sense. It's quite common. You go into a company, they have scalability problems, and they're optimized for write performance. And then their reads don't scale because they all have 19 joins in them. When we talk about writes, writes are completely different. For writes, what I really need to be able to do, I need to be able to do a write, and I need it to be durable, and I need to get it back later. Databases internally store an appending log of events. It's oftentimes called a journal or a transaction file. Internally, what they then do is they take out of that transaction file and they write into some known form that they're using for their reads. Wait, isn't that CQRS? What? You know, that new pattern that people came up with? It's a pattern that's been around for a long time. Not all databases work this way, but a lot do. Now, years ago, I gave a talk about event store. I guess it was like 2 years ago now, 3 years ago. And I went through our whole transactional model. And what we use is it's basically a log structured merge. And someone came to me afterwards, and they're like, that's the same as Cassandra, so your database is the same as Cassandra. And it's like, well, okay. SQLite works this way too, so therefore Cassandra is SQLite. This makes no sense. It's an academically backed transactional model. It's not something that any of us came up with. What's interesting is the thing that I write into. Is it sorted string tables? Is it a B+ tree? There's lots of things I could be writing into it, and that's where the interesting parts of databases are. It's on the reading. Now, to be fair, there are some systems today that update in place. And they're going to become more common because we have SSDs now. But when I talk about writing, just taking an event, appending it to the end of the log, and making it durable so I will be able to get it in the future is a really good model for writing to. By the way, it's pretty fast, too. You can pretty easily get yourself up to 50 or 100,000 writes per second, like without thinking too hard. It's also append-only and immutable, which is nice. You get benefits from being immutable. For writing, this is all I really need. But reads and writes are not my only form of separation that I can deal with. There's another form of separation which is really common, and that's time. If I were to go look in a financial domain, this separation is made explicit. How many of you have worked with finance before in some way, shape, or form? Okay, so what we're talking about is the difference, for instance, between intraday and interday data. Today in finance is different than any other day in history. And they have completely different models and different SLAs, different everything about how to read today than how to look at any other day in the history of time. This is a very common way that you'll find a separation is based on the time and age of your data. And you might have different models for right now compared to 15 minutes ago. We ran into a problem that actually did this. Actually, I guess I've had 2 or 3 of basically the same issue this year. So a company is basically going through, and they've got a very large multivariate problem that they're dealing with. So they have Hadoop, and they do a giant MapReduce job across billions of records to get back the full answer to a multivariate. Only problem is, they need like 80 Amazon high I/O nodes to do this query for a day. So how much do you think this query costs them? Like tens of thousands of euros to do a single query. And they're doing it once per month. The problem is the business wants to do it at least once per day. So, do you start paying 100,000 euros, 200,000 euros a month to Amazon to do this query? And what we did is we broke apart the problem. And we gave separation like what we're talking about here. So they would still only run the query once per month. And that query would give you perfect results across the entire multivariate. Then we built another layer. And this layer was a little complex event processor. And what it would do is it would listen to the messages in real time as they were happening. And there are some aspects of the multivariate that they were more concerned with than others, like, for instance, the ones that they were constantly using and spending money with. So what it would do is it would monitor those and look for new patterns of things coming in. And then what it would do is it would generate tiny slices of the big multivariate to recalculate. So instead of calculating the entire MapReduce job again, just do this one tiny slice of the MapReduce job. And this is very common. We will end up with two models here. One was a complex event processor. The other is a big Hadoop query. The complex event processor is precise. Basically, something looks back compared to its results. Then those go back again. The complex event processor is a single server. And it could keep up with the log without any problem. This is common. And I think it's one pattern I've seen 3 times in the last episode where people have a problem with large now, the problem people are going to run is if I want to have multiple models, how do I find models to actually work? How many, let's say, a third normal database and then a report or a database? The big problem is that they're out of sync with each other, right? How do I really, in an organization, run with multiple models and keep reasonably answers between all of them? And this is what I see people to do today. So what they'll have is a client that, let's say, talks to a domain model with Hibernate behind it. Then they have a third normal form database, and they have a message bus. I really hope all of you, if you have not done it before, will go watch Martin Fowler's talk. Does my bus look big in this? And then on the other side of the bus, they'll have 3, let's say, models. So we have OLAP, we have a graph database, and we have some stream processing that's occurring. How many of you have tried something like this before? I see this all the time when people are talking about event source systems, and they'll put this up on a slide in a conference. But there's a lot of issues here that will cause problems. The first is, I have to write to a third normal form database, and I have to publish to the bus. So what do I need now? OK, so I write into the database. I'm going to publish into the bus, and somebody pulls out my power. I'm going to need distributed transactions of some form, let's say between SQL Server and MSMQ. Avoid distributed transactions like the plague if you can. By the way, has anybody here ever worked with Microsoft DTC? I have to say it's very aptly named in France. Now, there's another issue you're going to run into here. What happens if there's a bug? And I've always said, I know none of you guys would put a bug in, but it was a junior. And that junior might have been you yesterday. But let's say I put in a bug, and I don't end up with the same information being written through Hibernate that I publish on my bus. Now my models go out of sync with each other, and I'm going to end up with big problems over the long term. But there's some other more sinister problems that come up with this that you won't really find until you go to production. What happens when I want to bring in a new model? How do we populate it to get its initial state? Maybe we do a migration off of the third normal form model to get its original data, and then we'll start pumping it messages from then. It's a big or people doing a lot. I'm going to have a control channel, publisher on the other to send me all the old. So you run into a lot of particular one. The biggest anti-patterns I see in systems. So if I do a message over a control channel, it's just odd in the first producer and you shouldn't know who consumers are. But this message over. Okay, so now you for my queue, all the events of history. Do with the events coming in. Do you wait until later and then do you put it in the middle of all the old events that you're replaying? There's a huge amount of complexity that comes up from inside of this model. And we're actually looking at, instead of doing a third normal form database, try something like event sourcing. Most of these problems actually just fall away and disappear. So here is another way of doing it. A client who writes to a domain model who writes, let's say, into an event store. And this thing is just a historical log of all my events. Then I have OLAP, I have a GraphDB, and I have stream processing, and they're all pulling their events off of that historical log. And they just keep saying, with checkpointing, it's a client-driven subscription. A client-driven subscription might be something like RSS. Well, can you imagine if we tried to get my blog to work in this way? So you want to read my blog? Cool. Send me an email, and I'll set you up a RabbitMQ queue. And then I'll respond with what your queue is. And as I write new blog posts, it'll appear in your queue for you. But then you said, but I want to get the old ones too. Well, then you send me an email, and I'll say that I'll put all the old ones into your queue for you. There's more than one way of doing a subscription, and a client-driven subscription is something like RSS, where basically I have a set of data, and you can imagine that it is numbered. And then what you do is you remember what's the last number that you read. And then you say, give me the next n after this number. And I go, OK, here you go. I don't know where you are in your subscription. Only you know where you are in your subscription. And very often for these kinds of systems, that actually turns out better. What happens when we add a new model? So I have a new guy come, and he wants to subscribe to my blog. Do I care about this? Does he have to send me a control message? No. He comes to my blog, and he says, OK, go all the way back to the last post that was ever written. And now go previous until you get caught up, and then continue, and your subscription will continue. I don't need to know when you want to reset and start reading over from the beginning. You don't need a control channel with me anymore. There's some other things that this allows you to do. Could I have 5 OLAP models, all just sitting next to each other? What configuration would need to be done on this side to add a new model over there? It's 0, because it's client-driven. And this works really, really well as an architecture for trying to keep things in sync. Now, the problem when we were back here and we were looking at the publish versus the third normal form is that you have 2 core sources of truth in this system. When I go through and look in this system, there's only one source of truth. The one source of truth is my events. And by the way, never, ever tell your DBA this, but that beautiful SQL database on that side is nothing but a cache. In fact, I will go drop database and rebuild it. If you find that you've got a horrific bug in building out one of those models, delete it. Start your subscription from 0 again, rebuild it. Now, to be fair, you normally wouldn't delete it and then rebuild. What you would normally do is you would rebuild, switch from one to the other, then delete the old one. Because sometimes these things can take a while to build, and you don't really want that. Now, there's another side to all of this. Oh, man. Oh, that's right. I had to export my slides to PDF. So this is actually a Rube Goldberg machine. And it's animated, and there's actually crap moving all over the place. Apparently, animated GIFs don't work well inside of PDFs. Should have thought about that. There's another side to all the things that we've been talking about. The other side is operational complexity. Now, on most systems, you don't want to come in and bring in, let's say, 7 different databases. Why? Because if I bring in Neo4j, somebody in operations needs to know what the hell that is. How do you monitor Neo4j to see if it's healthy or not? What data durability guarantees and what things do I need to worry about with Neo4j? How do I back up Neo4j? Somebody needs to know all this stuff. So every time you add a new model, you also have a trade-off of operational complexity in that you're increasing your operational complexity. So it's not just, let's create new models for every single little problem that we have. If I were to walk into your organization and you were to say to me, you know, Greg, we looked and we decided to go with SQL Server full text indexing over Lucene. We know Lucene's better, but we only have 100,000 rows of data. And to be fair, it's not really growing that fast. And it's good enough inside of SQL Server. It works. OK, fair play. That sounds like a well-reasoned, thought-out decision. You were taking both sides of the trade-off, and you didn't want to introduce operational complexity. I don't want everyone to go off and start saying, Greg told me we should put 10 new databases in production. He said, I have his slides. And actually, I probably should have put a note on top of that so that if you review the slides, you'll understand what that means. But there is two sides of this coin. There's operational complexity, which is on the side of having specialization. When I have specialization, I can very often get many performance benefits out of it. I can get simplicity out of it if I understand the mental models being used. But I introduce operational complexity. Now, to go through and summarize some take-home points. Just appending to a log is a great model for writes. This is exactly what most writing systems want to be able to do. This is how most databases work internally. Events being written to the log works very, very well. We can look at CQRS as being one form of separation where we might start wanting to have different models. Because reads are different than writes, and they have different both functional and non-functional things associated with them. But the biggest takeaway I want people to have is that every database on the planet sucks in their own unique ways. If I go through and I tried to use an OLAP cube as my transaction processor, that wouldn't turn out so well for me. If I were to try to use a graph database to do a bunch of set operations, it's not going to work out very well for me. If I want to do set operations inside of an object database, it's not going to turn out well for me. If I want to build a graph in SQL, it's not going to turn out well for me. If I use Mongo, it will not turn out well for me. Sorry, I just have to take a piss out of Mongo. But every database on the planet sucks. The trick is understanding where they suck. They're all really good at some problems and really bad at other problems. Choosing one for everything is normally where people start having problems. Open yourself to allowing more than one form of storage inside of your system. And it will help a lot in getting rid of the accidental complexity that you guys are dealing with. So at that, because I think I'm actually over by a couple minutes, I will let everyone know that apparently there's beer. It's a reward for having sat through my talk. And with that, I will thank all of you guys for having me out. I hope everybody had a good conference. And merci.